That I'm not probably the best person to answer that, but I do have an attitude to checking itself, which comes down to the attitude of the individual. So it starts with people doing work, which have outcomes, done real outcomes, have to take responsibility for the validity. The fact you can do 10,000 computations doesn't mean you don't have to spend the time to understand whether they've been done properly or the results are appropriate. So it starts for me with the engagement and attitude of the individual and accountability, if you like, to their profession before you get to checking. Because I had a time working in New South Wales and Australia where there was no regulatory environment really for structural engineering. Every structure built had to have a piece of paper with it that said, I'm a practicing structural engineer and I stand by this design. Yeah. And very little went wrong in New South Wales. At the same time, in Singapore, they had 3 different layers of checking, and actually more things went wrong in Singapore in a similar time period. So checking is also sometimes a false, as in independent checking. But checking your own work and feeling absolutely responsible for the outcomes of your own work, I think is a vital thing.
Can I just jump in there then, just to sort of build off of that? Because I wanted to come to this, Nick, here. Because I think this question, I mean, obviously I started from a structural engineering background, I've moved into computing, and I've therefore sort of seen how 2 different industries deal with the problems of verification and validation. And I do wonder if some of the lessons to implement actually come more from the software industry than maybe from the structural engineering profession. I don't know, Nick, how do you, like, for example, in Ramboll, when you're working on a new tool for somebody, I'm assuming there'll be some process of some kind. And I think one of my biggest concerns actually as a software engineer is kind of, as Nick over there mentioned earlier, as these companies are going through the maturity phase and they're learning these processes, there's this intermediary bump where they might do something wrong. And if it's not picked up, that will lead to failure somewhere down the line. And so it exacerbates the problem we talked about earlier of the senior management not being able to inspect the results, even worse than before, because now it's being written in random programming languages or visual programming scripts. How do you tackle that? How do you feel confident that what you're doing is safe, is correct, is good enough for the rest of the team to use?
Yeah, that's a great question. So I guess the approach that we've been taking at Ramboll, because senior engineers who are going to be checking, we need to check the calculations or analysis methods, not necessarily read the code. So as the engineers who can code end up needing to kind of write very detailed methodologies of how it's being done, and then that gets approved in principle by kind of more senior engineers. And that's like the initial step. But then also there is the checking results. So like, thankfully, known how to do calculations in Excel, and our senior engineers are comfortable with that. So we often kind of run these tools in parallel, kind of like as Tristan was saying, with the kind of have more than one method to do some sort of analysis and make sure that the analysis results tie back and kind of confirm each other. I think more generally though, like going back more to like an AI sort of topic, AI makes, well, especially if you've seen like the newest version of ChatGPT 4.0 and stuff, large language models like ChatGPT make it a lot more easier to interrogate data, and it gives you access to a lot more knowledge at your fingertips. It gives you knowledge in a very kind of customized way. But I guess if we just take that one at a time, so whereas a more senior engineer might not be comfortable with writing code to kind of see what exactly is happening in the model or filter results or that sort of thing, with something like ChatGPT, ChatGPT can write that code for you, which then does that. And actually, the newest version of ChatGPT does analysis by actually writing Python code, which can actually query the results and help a senior engineer who kind of is not comfortable with that understand what's being done. So that's at the senior level. At a more junior level, you can also use use these models which kind of basically know all the information. Like I basically, one of the things I see, one of the things I think will happen is that companies will start putting all their knowledge and stuff, and it will be accessible through ChatGPT, and that will help give engineers, maybe more junior engineers, the ideas of what they should check, and kind of gives ChatGPT is very good at kind of tailoring information to your needs. It knows everything, and it can, based on that information, it can tailor that to your needs. Could even give you references back to the original documents and articles which it came from, which is very important from an engineering perspective. It can kind of help bridge both sides. It can help provide more senior engineers the know-how to interrogate the data, and kind of give more junior engineers the ability to understand what the problems are, ideate kind of things they should look out for, and just ideation in general. Like I talked about coding before. I think that sort of technology can help bridge the gap in a sense.
Great. I think 100% I do agree. You feel like it provides a way to kind of explore and explain things in clearer ways. I mean, I should note other LLMs are available for those. We are not sponsored by OpenAI for anyone who's interested.